Okay, so we've got a boy moves on a skateboard at a constant velocity of 3 meters per second. So we've got a boy on a skateboard going at 3 meters per second. And the combined mass of the boy and the skateboard is 40 kilograms. He catches a bag of flour that is thrown at him at 6 meters per second. So we've got some flour coming this way at 6 meters per second. It was a 5 kg bag, 5 kg bag. And determine the velocity of the boy after catching the bag and the flour. Okay, so basically what we have is, well, this was going at 6 meters per second. So we had the momentum. So we know momentum is always conserved. So the momentum here is 3 times 40. And the momentum here, it's going in the opposite direction. And momentum is a vector. So it's -6 times 5. And so that initial momentum is 120 minus 30, which is 90. And now that's going to equal the momentum after. So that is also P after. And now he's caught the trolley. I mean, he's caught the flour. No, I'm reading ahead to the second question. So he's caught that. So the combined weight now with him sitting on the trolley is 45 kgs. With him sitting with the flour, sorry. And so that's going to be the final of them combined. And it's going to be 90 over 45 equals VF. So V final is equal to 2 meters per second. Okay, in the same direction that they were traveling, because we see that we took 3 meters per second as positive.
Yeah.
So we just can say in original direction. Okay, second question. 2 trolleys of a mass 0.2 kgs and a mass of, so 2 trolleys, mass 0.2 kgs and 0.4 kgs are moving to the left at 3 meters per second. And 3 meters, to the left. Okay, so we need to do that way. Trolleys are attached by a compressed spring. Okay, so the trolleys look like that. And they've got a spring attached to them. The spring is released and immediately trolley A moves to the left at 4 meters per second. So trolley A is now going at 4 meters per second. State the principal conservation of linear momentum. Okay, well, linear momentum is conserved. We know that. Now they say calculate the velocity of trolley B. So they want V of trolley B. Okay, so, well, let's look at the initial momentum. So the P initial was, the total, so it was 0, 2 times 3 plus 0, 4 times 3, which was 0, 6 plus 1, 2, 1, 8. Okay, G dot MS to the minus 1. So now that is equal to the final momentum, which we can calculate as 4 meters per second. That's the first, that's trolley A. So I'll just do that I'll do A in green quickly. So that was trolley A at 0.2. And B is trolley B, and that was 0, 4. And we wanted their combined momentum. So we wanted the final of the trolley B. So 4 times 0, 2 is 0, 8. So we would have that over here. So we'd take that off. And so you'd have 1, 8 minus 0, 8 equals 0, 4 times the V final, right?
Mm-hmm.
And so V final is going to be 1 divided by 0, 4, right? Which is 2, 5. And we've got a positive answer, so it's also to the left.